Okay, good afternoon to all of you. Welcome to MAT123, Abstract Algebra. This is a course offered by LD Woosley, Bethany College. We welcome everyone. This is our week number 9 as we continue on our midterm period. We welcome everyone as well as our students. Not so sure where they are right now. Nevertheless, we will continue on our discussion. So particularly, we are still on Module 1-4, particularly groups, no? Actually, discussing some groups. Okay? So, ayan, nasa na ba sila? Parang ano. Ayan. So, welcome everyone. So, we're also live at our YouTube channel, CBC Ministries online page. Welcome, guys. All right, let's open our prayer. Though this will be a monologue if there are no students. Let's pray. Father in heaven, we thank you for this day. Thank you for the opportunity where we could continue on our discussion, particularly on groups and subgroups eventually, knowing their properties and some of the derivable properties from the known properties of groups, primarily associativity, identity, and inverse properties, O Lord, that we may recognize this throughout the sets of numbers that will be presented. I pray, Lord, that the skills conceptually and computationally will be developed among the students, that they may become competent teachers, and that they may have that they may continually develop also their skills and also their teaching careers that will be continually magnify your glory. We thank you. We honor you. This is our prayer in Christ's name. Amen. All right. I have not seen any notice from my student. Nevertheless, we will continue today. So we are continuing here on our discussion for a while. Now, I need to change some of my... Napakainit po ngayon. Pasensya na mga kapatid. Napakainit ng panahon. Ngunit gayon pa man ay nagpapatuloy tayo. Actually, I came from my client call. I have 2 client call outside. I need to rush home so that we may continue our broadcast today. For week number 9. No? Kalahatian na ng semester. Week number 9 na ngayon. Ibig sabihin, kalahatian na siya. No? So we praise the Lord for that. Though computed na natin yung mga grades, pero saka na yan. Now, this would be our case. Perhaps I could change my... Ayan, so takpa naman pala yung mukha ko, no? Nevertheless, hindi na. Ito na lang. So, i-maximize ko na lang siya para we could have a maximum. So this would be the modules. We already defined this. Oops, laki. Yung tama lang. Yeah, okay, all right. So by definition, we have here by definition this group. All right, I wonder where is Micaela? And Dale, are you there? Are you on the background view? Okay, you could chat me, no? Chat, just give me a chat. I don't know what, wala sila, no? So yung mga nakakita ng link ay yung mga, okay. Okay, we're continuing here. So far, we have defined a group as a set G, no? And there is this binary operation, no? On such that G is closed under, no? So under that that operation, whether that be multiplication or addition, so that's defined under the binary operation. And for the test case, we have all of the elements should be elements of G. So even the result or the elements are G, and this should be associative. In this definition, you will notice clearly here, A asterisk B asterisk C is equal to A asterisk of B asterisk C. So we have here associativity as a matter of review, and ultimately we'll be discussing some exercises afterwards. Yeah. Okay, so this will be next week ay week number 10 na. Week number 10, 11, 12, no? Final exam, midterm exam na. Parang kailan lang. All right. So, of course, the next property aside from the associativity is identity. Okay? There's an existing element wherein E should be an element of G. So, dapat makita natin E nandun sa G. Pag wala siya doon, hindi siya group. Okay? Such that there is this identity asterisk X equal to X asterisk E, whatever it is. No? Perhaps you could define it as a multiplicative identity or an additive identity, whichever is the case, and that would be equal to itself. And then the last one would be the inverse of that particular element or set, wherein A asterisk inverse of A or inverse of A asterisk A is equal to that identity element. Okay, so I suppose these are clear. It's a matter of review that we need to consider. Okay. Hello, Michaela. How are you? Okay, so we're just reviewing so far. I'm not so sure if Dale is around. So, as a matter of review, of course, we have infinite groups, including real numbers and addition. So they have the additive operation as far as binary operation is concerned. In terms of addition, these are groups. All right, for real numbers, also with integers, and then rational numbers, and even in complex number, all of which considered as an infinite groups, no, using addition operation. So there's an addition operation here, no? And then another infinite group, which is the invertible matrices under matrix multiplication. So there is this case for matrix that is part of the group, and sometimes we denote it as a general linear group of order n. We also would extend this to complex numbers. Yan, complex number text also mentions an infinite group of complex numbers in the form e raised to j theta. So this is actually a complex form. I don't know, Michaela, if you still recall the different forms of a complex number.
Yung polar form po, rectangular.
Yes, polar, rectangular. You have trigonometric, trigoform, and one of which is your exponential form. No? In the form e j theta or I theta. No? Of course, r is equal to 1 for this case. No? So this would be, of course, theta is element of real numbers under multiplication. Denoted as, so you have your u set and your dot operation. So this is an example, an infinite group of complex number as well. And also we also applied this to modulo and under addition. So you have your z sub n integer set. Now for instance, z sub 7, meaning integers from 0 to 6, because if you count them, it's 7. And then you have the modulo addition that we have discussed previously as well. No? The modulo addition is a group and nth roots of unity in a complex plane. No? So nth roots, naalala niyo yung complex plane, no? Whenever we extract the root, we're actually dividing the entire complex plane into the number of the roots. For instance, cube root, you divide the entire complex plane to 3. And then we could reflect the angle for each. No? So that could be the roots of unity of complex plane, form a finite group under multiplication. So this is a finite group. Even the modulo, of course, is a finite group. In fact, these are isomorphic binary structures. Now, pag isomorphic, alam natin yung definition, no? Homomorphic, no? Meron siyang homomorphism. At the same time, mayroon siyang one-to-one correspondence and onto. So that makes it isomorphic. And if it is a group, this is what we call isomorphic groups. No, isomorphic group siya. So meron siyang one-to-one, may onto, saka may homomorphism. No, homomorphism din siya. Okay? And then of course, another special type of group is what we call abelian. If its binary operation is commutative. Now, because by definition, it's just associative. We don't assume commutativity if there is associativity. Not yet. Now, because there are cases that even though it's associative, meaning different pairs of operation, it may not be considered commutative. Whereas, if the group is commutative as well, it is what we call abelian groups. Based on this, abelian, its binary operation is commutative. Ayan. So here are the examples of abelian, not just a group. Of course, real number with addition operation, they are commutative. Addition is commutative. And then you have your integers with addition operation. We have your Q, rational, addition, complex as well. You have the U, no, as defined here. A complex number, a complex number definition, and then under dot multiplication, and then modulo. Halos pareho, lahat ng diniscuss dito ay also an abelian because the invertible n by n matrix under matrix multiplication is not abelian because basically the multiplication of matrix is non-commutative. So if it's not commutative, it's not abelian. But still a group. Of course, it's a group but not abelian. So there are sets here. You have your Q. Asterisk would mean a non-negative, so it could be Q, and then real numbers. You have rational numbers. R and C are non-zero numbers under multiplication abelian groups. Okay, so an example here, as a matter of review, we can also consider multiplication modulo n in z raised to n. For example, of this case, as listed here, for this phrase, 5, modulo 7, 6. So meaning there is 2 in z sub 7. So meaning this is equal to 2, no? Because 2 is the remainder. If we will multiply 5 and 6, which is equal to 30, we could express that into modulo 7 such that 4 times 7 is 28 plus 2. So the remainder is 2. Okay, so we could try to test the set 1, 3, 5, 7 with multiplication modulo 8 is a group. Okay, and give the table, no? Give the table for this group. Pwede natin gawin yan. So yung 1, 3, 5, 7. I think I have drawn this last time, no? You may recall, Micaela. Para gumawa tayo ng ganito. Let me check my files here. Last time, no, we have a Word document for this. Na parang meron tayong ginawang table. No? I think we have a table. Let me check my files. I wonder where is Dale, no? Have you seen Dale, Micaela?
Hindi po, sir.
Tagal magbukas ng Word ko. Tagal. Kasi nasa cloud to. Hindi pala to. Anyway, I'll just open some files here. Okay, sound check para nawawala ako. Baka mawala na naman tayo. Ito rin yung nangyari sa akin nung last time. Though I already made some improvements on my yan, ako lang to. Kasi mukhang ano na naman eh. Nag-i-stuck na naman siya. So I need to for further recovery. No? Alright, I wonder where's Dale, no? Dale, are you watching now, Dale? Yan. So anyway, I think Dale is watching now in the YouTube but hindi pa siya. Dale, mag-message ka nga dyan, Dale. Dali lang, Micaela. I have some glitches here. But kailangan yun. Okay, Dale, are you there? Give me a message, please. Dale? Okay, let's continue. I cannot find the file. All right. So maybe later we will have this table, no? Sometimes it's called K-list table, no? This multiplication table are K-list table. No, K-list table ang tawag dyan. Ayan, Dale. Thank you, Dale, ha? Ayan, welcome, Dale. Ayan, he's with us. All right. So we have here another example. Consider all n by n matrix with determinant either 1 or -1 under matrix multiplication. That's this form group. Maybe later we could do some exercise. We'll just continue with some discussion here. Hindi makapasok si ano. Oo nga, siguro may problema yung stream. O ang speculation ko dyan, yung browser ang may problema eh. Hindi optimize yung browser for stream, no? So dapat may optimization. Lalo na pag mobile, medyo hirap. Pero ito, katulad nito, yung browser ko nakapasok. Ayan, no? So doble cara. So para may continuity, no? Oh, hindi kita maririnig hanggang di kita na-accept, Dale. Yun. Hindi kita ma-accept. Hanggang hindi kita nakikita, hindi kita na-accept, di kita maririnig. So ganun lang siya. Yung katulad nitong aking ano. Ayun. Naku. Start pala yung mode, ano yan. Parang echo. Anyway. So let's continue. So another theorem here, no? Tapusin lang muna natin theorem dahil we'll do doing some exercises. Okay? So another, there are implications of having a group. Now, for instance, if there's a group, set G with the binary operation asterisk is a group, then it implies that A asterisk B and A asterisk C is equal to A asterisk C. It follows, it implies that B is equal to C. Or in like manner, if you have B asterisk A is equal to C asterisk A implies B is equal to C. So, ang tawag natin dyan, these are sub-properties already. These are actually implications of being a group. We have what we call left and right cancellation laws. You could cancel left and right. Assuming that we have the same, we could cancel A for number 1. What remains is B equal to C. For instance, also in number 2, we could cancel A, therefore B is equal to C. So of course, A, B, C are elements of G. So that would be the left and right cancellation laws. Okay? So that's another property that we need to take note. Ayan. The following result shows that the equation of the form AX is equal to B and Y is equal to Y asterisk A is equal to B have a unique solution. Unique solution. For instance, so therefore, what would be your what is the implication of this, Michaela? Equation in the form AX equal to B and YA is equal to B. Have unique solutions for A, B element of G. This implies that the table for group must have every element of each group in each row and each column of the group. So, dapat makikita yon. Yung X, yung A and B, saka yung Y, ay dapat lahat ay element of G. Alright? To make it a group. Then another, so we have here, so this one here, so this is a unique solution X and Y. So there are unique solutions. Are unique solutions A. Kasi hindi sila automatic commutative, no? Remember, commutativity is abelian, but you could be a group without an abelian or commutativity. So we could consider here as unique solutions X and Y, such that A and B are elements of G. In the group, there's only one element E such that there's only one, no? Wala nang ibang element na tinatawag nating identity element. Okay, nag-iisa lang siya. So in a group, for given A, there's only one element. Isa lang, one to one lang, no? Hindi marami ang inverse. Isa lang. Inverse is also unique, as well as the identity is a unique element. For each of the element, there is a unique inverse. So walang sharing ng inverse, no? So hindi pwede yun. That's another implication of the group. And then corollary. So it follows here. Let be a group. So for all A, B, element G, we have A asterisk B. The inverse of A asterisk B is equal to inverse B asterisk inverse A. So that could be proven sooner or later. This type of this property of a group. Then the theorem here suppose that asterisk the binary operation on set G, that is G asterisk, is a group if the binary operation asterisk is associative and there exists an element of G such as, this is what we call the identity element, E sub L, element of G such that for all X, there is this E sub L when multiplied to any element X would be equal to itself. That's what we call a left identity. Left identity siya kasi pwedeng right identity. No? Left. And then for each, kasi hindi pa natin titingnan yung associativity, no? No, but this is a left identity. For each A element of G, there exists an inverse of A such that inverse of A asterisk A is equal to E sub L such that A asterisk is the left inverse of A. Alright, so yan yung mga theorem natin. No? So left, it could be a left identity and left inverse as well. Okay, we have proof here. Some exercises on the book. No, we need to establish G sub 1, G sub 2, and G sub 3. So these are the properties of a group. For G2, for G sub 1, it is 1. No? For multiplication, the multiplicative identity is equal to 1. It exists. For G2, X element G, and consider X times this identity. For X inverse, left inverse of X we have. So what do you have here? So ang ginawa natin, nagkaroon tayo ng associativity by number 1. We prove associativity. Alright? Can you see, Micaela? We are showing here the associativity of this one. This is for number 1. We apply associativity. Tama ba? Kasi we are trying to imply that the inverse of X times or asterisk X asterisk E sub L is associative. So we could apply associativity. Then we all know that X sub inverse of X asterisk X is also equal to E L. Since inverse of X sa left inverse of A. So ano natira? Itself, no? Since it's a left identity, he treated one and on the right as any variable, including itself. So if you will multiply the identity, no? Including to all numbers, including itself, it will be equal to itself. So that's what we call left identity, since E sub L is a left identity. So we could see here that inverse of X is a left inverse of X. Also the left inverse of this one. However, left cancellation holds that inverse of X asterisk X is equal to inverse of X times E sub L by virtue of the definition of identity. So implies that X is equal to X asterisk E sub L. Therefore, E sub L is a left and right inverse this time. So pwede siyang baliktaran. Saka lang natin napatunayan na baliktaran yung pagiging identity. Same as true with the inverse. It follows also with the inverse here, no? So the left inverse is also the right inverse as well. Of course, the previous result holds with left replaced with right. The benefit of the result, like the previous one, is the binary structure can be shown be a group by showing, of course, associativity. It could be left identity kasi ang implication yan, right identity lang, pero mapatunayan mo lang na left identity, okay na yan. And left inverse for each element. We know that we are then guaranteed the right hand identity and inverses if there are left identity and left inverse. Now you don't need to swap or to prove left and right. You just need to show the left identity and left inverse, and that would guarantee the right hand identity and inverse for as a group of sets. All right. Now, for finite groups, we can draw a table illustrating the binary operation as before. Since maybe sooner or later, now we will have some binary as we go on with the exercises, answering some. We may produce some Cayley's table. No? So this is the multiplication table developed by Cayley himself. who is one of the pioneer mathematician pioneering mathematician in abstract algebra as well, Kylie Table. All right, so okay, finite groups, illustrating binary operation. Of course, this had been discussed. And yes, on the page of our, maybe we look at the page. Ayan, may mga illustrations dito. Tingin ko hindi siya, ayan, ito yung table na tinutukoy dito. Ayan, so on page 43 to 45, Praley argues that there is only one group with one element. Ano kaya yung element ng one group na yon? O group with one element, Micaela?
One po.
Oh, it could be the identity, no? Later, we will look at that. Kasi ito yung correspondence niyan. So ito yung supposition ni, ano, actually mahaba yung argumento dito ni Raleigh. This page 43 of the book. Actually, ito rin yun. Actually, yung notes natin, simplified version lang nito eh. But I hope you could read these modules, Micaela. This is more, ito yung mas detailed discussion. But what we are looking here only is the module slides. Or the module slide. But this is I also shared the entire book, in chapter. So ito rin yun, possibly given axiom, of course. So for instance, we have asterisk. So pwede na natin mabuo kanina yung modulo, modulo 8. Di ba, modulo 8 dito, under multiplication. So yung 1357 is a group, is a finite group. Yung 1357. Hindi nga, gagawin natin to mamaya-maya. So this one, so ibig sabihin, hindi lang siya left, right din dapat. Para magkaroon ka ng x and y multi-product here, no? So if you have elements here, so yan, meron kang A prime, which is correspondence to E. Alright, so yan yung mga dito eh. But anyway, etong table na to, 419. So there are correspondence, pansin natin may E. And then yung A in itself is E as well, no? So wala siyang no? Ibig sabihin, A in itself is an inverse. But anyway, later. So yan, yung magagawa tayo ng table later on. So perhaps hindi ko lang matansya kung saan ko ilagay yung aking Okay, tapusin muna natin to. Then we will answer some exercises related to this. So yung, of course, kung 1, meron ka lang isang element in itself pa rin yun. Tama yung table kasi magkakaroon ka lang ng element E, inverse ng identity, Micaela, ano sagot? What's the inverse of identity?
Identity po.
What's the inverse of the identity? For instance, in a multiplication operation or asterisk. What's the inverse of the identity?
Identity po.
Identity rin. Tama. Identity rin. So, yung kanina, yung table na pinakita natin sa kanya, siya rin yun. Yung E, saka yung A, siya rin yun. Kasi, when you get their product, it's still identity. No? Of course, magkakaroon ka lang ng product na identity kapag inverse to each other. That's the only time you will have identity is inverse to each other, inverse to itself. So, ganun ang identity. Kaya nga siya identity. No? Itself multiplied by its inverse is identity. And the identity is the variable itself. So, kaya na one of a kind yun. No? May element na kung saan identity lang ang nakalagay. Alright? So, yun yung argument dito. There's only one group with one element, only one group with two elements, and only one group with three elements. Now, technically, all groups of these given sizes are isomorphic. So, we know the definition of isomorphic already. Now, this is a historical note, no, as far as the development of multiplication table is concerned. For groups is sometimes called the Cayley table or Cayley table for a group. This is due to the fact that Arthur Cayley is the first to introduce the idea of group in his 1854 paper on the theory of groups. And depending on the symbolic equation, theta raised to n is equal to 1. Now we have the philosophical magazine. Now, this work is available, no, which can be found in Google Books as well. Now, an example of the following tables. No? So, ito yung mga tables na na-create. Of course, we have 1, alpha, beta, gamma. So, of course, following, yan, no? So, yung, in a way, para siyang, kung identity lahat yun, ibig sabihin, inverse in itself yun. No? Inverse to itself. Pero hindi siya equal kay 1. No? But anyway, sige, let's continue. Let's solve some problems here. You recall when we stopped? I think I already assigned something. Ayun, inverse identity. Yung inverse ng identity is equal to itself. No? Kunyari, inverse of 1. 1 is the identity. Inverse of 1 is equal to 1. Kunyari, sa addition naman, 0 minus 0. 0 is the additive identity. Minus 0 is the inverse of the additive. 0 minus 0 is still 0. Or 1 divided by 1 is equal to 1. So, yun yung parang lumalabas na katumbas niya. You still recall, Micaela, saan tayo natapos dito? Sa matrix na yata tayo, no? Tama? Matrix?
1-4 po, sir.
1-4.
Diyan po yan.
Sa matrix na, no? 11.
Opo.
I think I assigned something previously, no? So just take note of the previous lecture.
Opo, meron na po.
Sige. Ayan ko pa ng konti. Kaya pas go ng 250. 300 siguro. Parang may namali akong na ano. Subgroups. Yan nga dito. Actually, may problema rin ng mouse ko. Hindi ko Kaya nagkakaproblema sa dragging. Dapat na kaya niyang i-drag to eh. Hindi ko alam bakit ayaw. Ayan, no? Buti pa yung touchpad ko. Alright. Okay, here, given 11, exercise 11 to 18, determine whether the given set of matrix under specified operation, matrix addition or multiplication is a group. Recall that diagonal matrix, square matrix, only non-zero entries are the main diagonal or primary diagonal from upper left to the lower right corner. So upper triangular matrix, now we know that this already definition, associated with n by n matrix A is a number called the determinant A, denoted as det A. If A and B are both n by n matrices, then determinant AB is equal to determinant A times determinant B. Also, the determinant of the identity matrix is equal to 1. And A is invertible if and only if the determinant is not equal to 0. So those are the parameters that we could draw. Okay, the first question. All n by n diagonal matrix under matrix addition. So, tinatanong kung yan ay group. All n by n diagonal matrix under matrix addition. So, kung group, anong ititest natin, Micaela? Pag group, anong ititest natin? Paano masabing group siya?
Associativity po.
Associativity. Ano pa? Isa pa lang yun. Ano pa?
Commutative po.
Hindi commutative. Abelian yun. Special type. Associative. Yes. And then, or commutative. Abelian. Abelian yun. But we don't need to test whether this is abelian group. Okay, yung nabanggit kanina, identity. There's an existing identity. And what's the last? Alright? The inverse. Inverse. So yung tatlong yan, dapat ititest natin to make it a group. Okay? So associativity, identity, and the inverse property. Okay, remember that. So sabi dito, n by n under matrix addition. Matrix addition. Okay? So titest muna natin associativity. Of course, I'll be using sample here for demonstration. We will call the help from our octave. Alright? So, buksan natin si Octave. Matagal ko na di nabubuksan to eh. Okay, Micaela, no? I want you to, do you have the link? You still have the link for Octave? Or I need to send?
Wala po.
Sige, send ko sa private chat. Sayang si Dale naka-mobile eh. Kaya mo rin, Dale, you could practice ha. Nandito naman sa private, ay hindi, wala ka nga pala sa restream. No? Ayan, sige. I want you to assign a 3x3 matrix in any elements, no? Assign that as matrix A, B, and C. And then we will test the associativity. Okay? Can you do that? Any values or elements of a matrix A, B, and C. That must be 3x3 matrix. Yan. Any value. Whatever you may think. Basta ang determinant not equal to 0 kasi mag-error tayo. Yun lang naman yung ano dyan eh. Yan, sige. Kahit anong number dyan. Alright? Letter C. Yun. Parang grade yata sa math yan. May 99. Hindi, joke lang. Alright. And then, there's letter D. Matrix D is equal to A plus quantity B plus C. So we're actually proving here whether in addition, matrix addition, okay, that's the answer. And matrix D is equal to A plus B plus C. A plus B quantity plus C. So yung associativity tinest natin. So para mat-try natin siya. Ayan. Ayan, pareho ba? Okay, pareho, no? So check for associativity. Now, is there exists an identity matrix or an identity that when you add to a particular matrix, it will be equal to the same matrix. What do you think?
Addition po.
Oh, sa addition hindi ito multiplication Addition. You think of a matrix that when added to that given matrix, say matrix A plus this matrix, the answer is matrix A.
Zero po yung
So zero matrix, still you recall how to produce a zero matrix on the order 3x3?
Hindi na po.
Ayan, sige, you could just create a 3x3 that has all zeros. Perhaps yan. Alam ko may shortcut yan eh. Parang zeros yata, then you will produce a 3. Anyway, so whatever. So you have, so say matrix F is equal to ayan, A plus E. A plus E. Ayan. Ayan, so ano nangyari? Ba't zero pa rin? Kasi inequate mo. Nabura, Micaela, kasi inequate mo sa F eh. So nabago yung ano, ulitin mo yung A. Yan. Ayan, so F is equal to, yan. Okay na yan. And then, how about inverse? So for instance, you create a matrix G such that that's an inverse of B. No, you don't do that. So hindi yan yung inverse na naiisip. Yan yung inverse of a matrix. Pero ang sinasabi natin dito, inverse of the operation of addition. Of course, the inverse of the operation is subtraction. So therefore, matrix G is equal to blank of B. Say blank of B. So ano kaya? Ano yung blank of B na yun? Para maging inverse of B siya.
B po.
Oh, say B naman. B naman ang gamitin natin. Ayan yung B. Oh, ano yung inverse dyan ng B in terms of the matrix addition? Or yeah, no, matrix G is equal to what of B?
Negative.
Oh, you try. Negative. Yan. Ayun. And then you have matrix H which is equal to B plus G. B plus G. Yan. So supposedly zero matrix yan. So ibig sabihin, you have proven associativity, identity, and inverse. So therefore, anong conclusion for number 11, Michaela?
It's a group.
Yeah, it's a group. Correct. Okay, let's proceed. Using the same given A matrix A and B and proving here, this time it's under matrix multiplication. Okay? So matrix multiplication. So yung C mo naman, ano ba yung ano natin diyan? So associativity, test of associativity. Okay. Kasi pag hindi siya sumablay sa associative, wag na natin i-test yung identity sa inverse, useless 'yon. So yan. Yan, o sige, sige. So yun yung letter D mo. Wow, laki. O yung matrix E naman. So pag sumablay sa associative, you don't need to prove all properties. Yun. Pasok, no? Ay, teka, may mali ako. Sorry Micaela. Hindi ako nagbabasa talaga. Diagonal matrix pala to. Sige. Pero yung okay yung pasok yung 11. Nakapasok yung 11. Yung nga lang, diagonal matrix. Magkakaroon ka ng 0 dun sa gilid. So, diagonal matrix. Okay yung 11. It's a group for matrix addition. But this time, make it a diagonal matrix. N by N diagonal matrix. Di ako nagbabasa. Diagonal matrices. So, sige, erase mo muna to para ano. So, yung for 11, pasok yon. Kahit diagonal or non-diagonal, pasok yung 11 as a group. So, eto lang, tingnan natin tong 12. No? You create another type siguro. Clear everything and create another matrix A. That's only diagonal. Diagonal, no? Ibig sabihin, yung main diagonal lang ang merong element. ABC ulit. ABC. Hindi, baliktad, Micaela. Ano, yung diagonal lang ang mayroong element. The rest is 0. Yan. Alright? Sige. Alright? Yeah, another one. Ayan, sige. So do the associativity for multiplication, matrix multiplication. Yun, lalaki ah. Anyway, you could verify. Yan, okay. Associative check. Okay, sige, prove. How about the identity? So you could use any matrix ABC for as your sample. Oops. Ang identity ay diagonal lang, ano, Mikael. It's also a diagonal matrix. Yan. Yes. I think may command doon sa ano, no, problem solving, Mikaela. May command tayo para doon eh, no. Siguro recall mo na lang. You want to produce an identity matrix right away without enumerating the elements, no. So anyway, sige, may command doon. That's a problem solving. Okay, sige, you could choose from A, matrix A or B or C as your sample matrix. Okay, so that is you multiply matrix C, no? Identity. Okay, yung inverse. Sige, inverse. Then later I'll introduce a counter example. Counter example. You could name the inverse of to another matrix name. For instance, yeah, G or whatever letter. Non-conformant. O tama na yung command mo kanina, Micaela, yung inverse. Yun na yun. Gagamitin mo niyan sa multiplication. Si inverse of G is equal to inverse of B. Yan. Then another matrix is equal to the product of B and G. So dapat ang expected natin na sagot ay identity matrix. Yan. So still recall in your problem solving, what's inverse of a matrix? It's the cofactor. Naalala mo yun, yung cofactor of matrix all over determinant. Yun yung sa problem solving natin, di ba? Yan. Medyo related siya dyan. But anyway, what we're looking here is if this is a group. Yes, it's a group. Alright? But however, before we conclude, I will have a counter example here. I'll have a counter example. So for instance, I would like to have a matrix M. So tama siya, no, for these particular examples. But perhaps if I will have a counter example, this is my counter example. So it's still a diagonal matrix but has zero entry. Zero entry. All right? It's still a diagonal matrix because there are non-zeros. However, there is one zero entry. Okay? And I would like to solve perhaps on the inverse of M. Right? What can you say? So there's one non-zero. There's one zero entry on the diagonal element. Or perhaps if I could say K is product of M times N. So it will be not a number. None is what we call not a number. Because if you multiply an infinite, because basically there is no determinant here. No? If the reason behind, because if you would like to solve for the determinant M, that's equal to 0. And by definition, inverse of a matrix is equal to the cofactor, whatever the numerator, it's the cofactor of that matrix all over the determinant of the matrix. And since the determinant of the matrix is equal to 0, what would be the answer, Micaela? You're dividing the entire 3 by 3 into 0, so meaning infinite.
Undefined infinite.
Infinite siya, hindi siya magkaiba yon. Ito kasi very large number. Very large number. No, samantalang yung undefined, not a number. Hindi natin matiyak kung number ba talaga siya. Ito, very large number. No, kasi when you divide something to a very small number, the answer is very large. What if it's equal to 0? So it's infinite. So yun yung, but if we will multiply an infinite with a number, that becomes not a number. That becomes an empty set. So what do you think? So there is a counter example, Micaela. Now this is true only if all are non-zero entries. In your diagonal matrix, there all of which are non-zero entries. But if there is zero entry, no, you will fail on the third test, which is the inverse of a matrix. So what's the answer for number 12? It is a yes or a no. Since I already provided a counter example.
Not a group po.
It's not a group, correct? Kasi kung maging not a group siya kasi linahat niya eh. Linahat niya. Very general yung presentation. Unlike number 13, if you look at number 13, diagonal matrices with no zero diagonal entry. In-specify niya na non-zero under matrix multiplication. Therefore, this is a group. 13 is a group. Okay? Make sense, Micaela? So, titingnan mo dyan kung ano yung mga yung mga properties. For 12, it's not a group. 13, yes, it's a group because in-exclude niya yung mga zero diagonal entry. Alright? Let's jump to 14. Okay, 14, this is a take home. Micaela, you work on number 14 as well as 14 and 15. 14 and 15. No? So you work on this. Dale, if you could hear us, no? So part of your homework is number 14 and 15 as well. Now let's move on to number 16. Okay, number 16, it's an n by n upper triangular matrix under what's that? An upper triangular matrix under matrix addition. So that's the entire, kasi yung 15, which is part of your take-home, under multiplication. Ito naman, under addition. Okay? Can you, siguro, kahit 2 by 2 na lang, Micaela, upper triangular matrix sa 2 by 2. You test the associativity, the identity, and the inverse property. Any 2 by 2 matrix. Yes, noted, Dale. Aside from that, previously I already assigned, no? You just review the other items. Okay. So this time 2 by 2, okay na yung 2 by 2. Pwede naman yung upper triangular dyan. So upper triangular. Yeah, correct. That's an upper triangular matrix. So addition tayo, Micaela. You test the addition. Under 16 is under matrix matrix addition. Yan. So sum ng A plus B plus C sa I. Sige. Okay, the same. So associativity is checked. How about sige, identity and inverse. Teka, can you command zeros zeros 2? Parang ganun. Meron tayong command na ganun, Micaela. Zeros, and then close and open parenthesis 2. Tingnan natin kung lalabas yung zeros, yung letter mismo. Letter mismo, zeros. Yan, 2. Ayan, 2. Sige, tingnan natin kung lalabas. Ayan, tama, no? Tama. Zeros 2. Ayan yung I naman, I. E-Y-E for identity matrix. O, sige, try mo lang for the sake of clarification. I, yung mata. Halimbawa, 3 by 3. 3. Gawin mo 3. For the sake of clarification lang, para alam natin. Yan. Okay. So at least, na-recall tayo dun sa problem solving, no? So yan yung diagonal matrix. Okay. Sige, you continue on identity. Yan. So pwede mo naman siyang balikan. At least may mga shortcut, no? Shortcut tayong naalala. Yung A. Of course, you already test associativity. Then identity. Alright? So You could choose any of the matrix given in terms of adding them to G. Yan. So, yan yung value din ng A natin. Correct. Okay. How about the inverse? Lost connection ako. Okay, and then you get the sum. Okay, so that's the identity. Okay, correct? Okay, so madali lang siya, no? Whether multiplication or addition. That's why take home again, number 17 and 18. 17 and 18, that's also your take home. Okay, did you take note, Micaela? So 17 and 18 also is take home. So thank you for that example. Okay, there are 19, no? Okay, let's proceed with this. Okay, given here, no, for 19, no? Let me Dale, did you note it, Dale? Also 17 and 18 is also a take home, part of take home. So we have defined here, we could define S as a set of real numbers except for negative 1. No? Define the asterisk as binary operation on S. No? As stated here, it's A plus B plus AB. Now, first is to show that asterisk gives a binary operation on S. It's a binary operation on S. So if you would like to prove this, Micaela, anong gagawin natin para mapakita natin to?
Ano po numbers?
Okay, you will show the answer is close. Is close to S. Ibig sabihin, all real numbers except negative 1. Dapat walang negative 1 na sagot. So you could choose, okay, I will open again the ano. You could choose any. No, kasi dito pinapaprove sa atin based on the definition of the binary operation, A asterisk B is equal to A plus B plus AB. So ang unang gustong malaman, show that asterisk gives a binary operation on S, meaning the answer is close to S. And S is defined as the set of real numbers except for negative 1. So here, please perform the operation using Octave. Oops, teka, sorry. May nadadrag ako hindi tama. Alright. So based on the definition here, okay, so we want to identify whether it's close to S. So you could assign any value of A and assign any value B and perform the indicated operation. It is a binary operation if it is close to S. So that's yung closure property, meaning walang negative 1 na dapat na sagot. Okay? Did you get it, Micaela? Please assign any values for A and B and then perform the operation indicated. And then we'll see whether this is close to S. That means all real number except for negative 1.
Sir, kailangan ko po mahanap yung values na magre-result siya ng negative 1. Tama po ba?
Pwede. Pwedeng ganun. O pwedeng gumawa ka ng kahit isang example lang na hindi negative 1 yung lalabas. Then later we will try to solve for such values of A and B such that the answer will be negative 1. Or is it impossible? No? So, yan. Sige. Okay. Magiging negative 1 lang siya kapag parehong negative 1 ng A and B. Kasi A, negative 1 plus negative 1 is negative 2 plus negative 1 times negative 1 is 1. So negative 2 plus 1 is equal to negative 1. So except for negative 1. So ibig sabihin, pag hindi negative 1 ang value, hindi magiging negative 1 yung sagot. Eh yun ang exception. So what do you think?
Kahit po yung values ng A and B, hindi po negative.
Hindi, yan yung A and B. Actually, ang sinod dyan ni Octave yung values ng A and B. Values ng A and B yan. Actually, kasi ginawa mong symbolic, no? O sige, ang i-identify mo A lang. A lang yung susolve. Comma A. Halimbawa, comma A. Tapos mamaya, comma B. Yan, para A lang ang solving. Pag comma A, negative 1. Hindi pwedeng maging negative 1 ng A para walang negative 1 na sagot. O yung comma B naman. Comma B. Yan. So yun yung ibig sabihin nun. Dito, simultaneous solution niya na. No? Kasi kapag hindi negative 1 yung isa, halimbawa 0, hindi mag-result sa negative 1 yun. So dapat ang A and B ay negative 1. Eh na ito naman ay ipinagbabawal. This is the exclusion. So therefore, so that's the proof of this is the case if only if either A is negative 1 or B is negative 1, which is not the case for AB element of S. So therefore, this is close. And if the operation is close to S, therefore, this must be a binary operation. So it must be a binary operation kasi close siya dun sa S eh. Okay. Next is to show that S and the asterisk is a group. Alright? So we could do some counter examples using Octave. Now by pwede kang mag-assign ng value ng A, B, and C pa rin. Pwedeng ganun yung maging definition mo. So we could assign any values except for -1, definitely. And then you test the associativity based doon sa based doon sa definition ng binary operation Now wherein ang gagamitin natin yung definition ng binary operation, which is this one. So you could assign any values for A, B, and C and then apply associativity. Apply associativity. Alright? And then you perform the operation based on the definition. Unahin mo muna yung A and B. So itong magiging definition mo, itong A plus B plus AB. Alright? And siguro you assign a particular variable for that. Para particular variable. Say D, E. Yan. G. Yan. Sige. Good. So yan. So AB yan. Sige.
Kaya po pag associativity, madagdag po ako isang variable.
Mamaya, yung ito AB naman, then BC naman gawin mo. Tapos mamaya, A times G, ay G times C. Diba? G times C. Tapos yung isa pang variable, BC naman, no? So A times H. So dapat pareho yung sagot nun. Ayan, G. Sige, gawin mo muna yung H. Yung H naman, BC naman. BC. So you take note of the value of G. Yan. Tapos yung sa H naman, BC naman. BC.
Saan po, sir, yung sa huli po?
Oh, kung anong ginawa mo sa G. Pero BC naman, BC. Yung H. Yan. Alright. Ngayon yung G, dahil AB siya, yung G sa C. G sa C naman. Sige, GC naman yan. Ayan, take note of the I. And then another variable naman, yung A saka H. A saka H naman. Ayan, o, di ba? Associative. Associativity yan. Okay, that's associativity. Okay, how about, okay, identity. Yung identity naman. So of course, we identify since this is, yeah, you could identify, no? So ano siya? It is 0 or 1. Mamili ka lang. That would act as an identity. Michaela.
Paano po sir na may addition po siya tas multiplication din?
Oo. So, halimbawa, mag-assign ka ng variable A and then yung susunod, either 1 or 0. You test whether which one, the result would be the variable itself. That's the identity.
Pero hindi po sa mismong binary operation po gagawin.
Oh, ang definition ng binary operation is still this one on the right side. So you will perform the right side operation. So either by inspection, of course, we will see the, but we don't need to show. If B is equal to 0, what would happen? What will happen to operation? B is 0, AB is 0. So therefore, it's equal to A. Therefore, A asterisk 0 is equal to A. Therefore, 0 is the identity element. Okay? Okay, make sense? Make sense on that? Pag 1 naman, pag 1, ano mangyayari? So hindi siya A ang sagot. Dapat in-expect natin yung same variable din. So it will fit on 0. Kaya dito A asterisk 0. So yung asterisk yan, not necessarily multiplication. It's just a binary operation. No? And the right hand equation is the operational definition. So you have, if you substitute 0, the answer is A.
Okay po.
Okay, so how about the inverse? Now, for you to solve for the inverse, okay, what would be the inverse since of course, you could solve for the inverse, no? could solve for the inverse since you have already the identity. Okay, so you need to manipulate since A is a variable and B is equal to 0. So you could, what would happen there? So pwede mong pwede mong ma-solve yung inverse. Okay, what do you think is the inverse?
Gawin pong sub minus po.
Sige, you try. Actually, mag-equate dapat sa 0. So, halimbawa, A asterisk B is equal to 0. A asterisk B, assuming B is the inverse of A, is equal to 0. Then solve for, you could do that on MATLAB. You could solve is equal to 0. Equate mo siya sa 0. Yung operational definition niya is equal to 0. Then solve for B. Yeah, you would show it in MATLAB, solving for B, such that A plus B plus AB is equal to 0. Okay, Micaela?
Medyo nagugulan.
Hindi, isolve mo. Use the solution on, hindi mo literally solve using octave. Use the octave. Equate it to 0. Then you could clear everything para hindi siya, Actually, hinahanap mo yung kapares ng A para maging sagot 0. Kasi yun yung identity element mo. Di ba? Identity element mo 0. So, hinahanap mo yung kaparehas ng A para maging 0. That's the inverse of matrix of A. Yan. Teka, i-clear mo kasi may values ka ng B, A and B. Clear mo lahat yan. Tapos make it symbolic. Yan. Yan. Then solve for B. Ayan, that's your, ano. Hindi, B. Make it B. Solve for B. Kasi mukhang A yung sinolve niya eh. Yan. Yan yung magiging inverse mo. Inverse of A. That's the inverse of A. Whenever you A asterisk of this would be equal to 0. Alright? So that would make it a group. Okay? So yan yung grupo. Group. Alright. So next. Alright. So for here, you're required to solve for 2 asterisk x asterisk 3 is equal to 7. Okay? So you could do that simultaneously if you want, or you make use some substitution. Pwedeng ano muna, 2 asterisk x muna, then you set x as symbolic, and then you assign another variable for that x, and then eventually that variable, asterisk 3 naman, equated to 3, then you solve it. Solve for x. Or solve for, yeah. Parang dalawang substitution ang mangyayari if you will make use of octave. Pwedeng i-solve muna yung 2 asterisk x, and then pag na-solve yung 2 asterisk x, yun ang i-equate, o baliktad rather, no? So masasolve mo muna yung 2 asterisk x, and then saka mo masasolve yung x. So dalawang sets of solution. So substitute mo muna yung 2 asterisk x sa isa pang variable, at yung isang variable na yon, asterisk 3 is equal to 5, is equal to 7, solve. Solve for that, and then babalik ka dun sa x.
Sir, question lang po muna dito sa B.
Yes.
Ito pong inverse, ano po siya? Sa binary operation lang po, wala siyang kung sa addition po siya or
Hindi siya defined as solely multiplication or addition.
basta po yan lang po inverse nung
Yan ang inverse niya pag ano yung definition ng binary operation. Kaya depende yan sa definition ng binary operation. Kaya dito binigay yung definition. Okay? So hindi siya solely inverse for addition or multiplication. It's the inverse for the binary operation.
nung A plus B plus AB po.
Oo. Pero siya yung inverse ng A asterisk B by this definition. Kasi pag nag-iba to, yung right side, mag-iiba din yung inverse mo. So hindi siya pare-pareho. Alright? So kumbaga, yung asterisk hypothetical operation. Hindi siya fixed sa multiplication. Okay, Micaela? Sige, please solve letter C. Oh, welcome, Michaela. Okay, can you do that? Or perhaps, since, can you test for commutativity? Kasi pwede natin i-commutate yung 2 and 3 para diretso na. Palagay mo, Michaela. Pwede mo i-test yung commutativity ng 2, ayan, sige. Halimbawa, 2 asterisk 3, tapos 3 asterisk 2. O yung test for commutativity para pwede na nating iurong. Magiging 2 asterisk 3 na siya. So hanapin natin yung 2 asterisk 3. Para isa na lang. Para hindi na magsasubstitute. Yung original plan natin, indirect substitution eh. Pero pag masisimplify natin yung 2 asterisk 3 such that we could apply commutativity, no? Abelian pala siya. So, for the meantime, we solve for 2 asterisk 3 and 3 asterisk 2, whether they're the same. If they're the same, it's commutative. Therefore, we could solve immediately for 2 asterisk 3, and then whatever the answer, asterisk x is equal to 7. And then we could solve for x. Make sense, Michaela? So solve mo muna yung 2 asterisk 3. O 2 asterisk 3 by definition. We're still here, We're still here on this problem. Ayan, yung operational definition. Apply. 2 asterisk 3 is equal to 2 plus 3 plus 2 times 3. Is it the same as 3 asterisk 2? Yan, pag na-prove natin yung commutativity, pwede nating interchange yung 2 asterisk 3 asterisk x. Then simplify 2 asterisk 3. Yan. Sige, solve for 2 asterisk 3 first. Okay, it's 11. How about 3 asterisk 2? So by inspection is commutative, but we would like verify 3. Yan. Yan, it's commutative. So, substitute mo na. Magiging 11 asterisk x na lang. 11 asterisk x is equal to 7. Solve for x. Ayun, mas mabilis. So, hindi na siya indiretso. Ayan. Yung indirect pala, diretso na siya. Ayan. 11 plus x. Ayan. Ayan. Is equal to 7. Solve for x. So, the answer is 1/3. Okay, 1/3 is the answer. Alright, so I think, sige, since further readings, we need some further readings here. So I want you to look into number 20. Okay, I'll be selective on this, no? So, okay, another take home is number 20. Number 20. Okay, okay, acknowledging, Ma'am Ilocanang Inday, salamat po, Madam. Thank you for dropping by on our live stream. We are discussing topics in abstract algebra. Welcome. Team Ilocanang Inday, salamat po sa inyong we're having some thumbs up raid here. Ayan, pakita ko lang. Thank you, Ma'am Churcher, for dropping by. Ayan po. Okay, salamat sa Team Ilocanang Inday sa pagpunta sa ating live stream. Welcome to our abstract algebra class. Ayan. Sinong gusto mag-abstract algebra sa inyo? Ayan. So, salamat sa Team Ilocanang Inday. Ma'am Churcher, thank you for dropping by. Patuloy lang ang pag-play natin, ma'am. Sabihin nyo lang kung monetize na si Apola. Ayan, thank you, Ma'am Churcher. Thank you sa lahat. I cannot really mention your name. There are too many to mention. But to Ma'am Ilocanang Inday, thank you for thank you for dropping by. And your thumbs up rate, okay? Sige, tuloy lang natin to. Okay, number 23. Number 23. Okay. And then the 25, which is true all false. True all false. Number 25. So hanggang dyan lang, yung mga additional natin. Additional topics, and then we will move on. So ito naman mga na to, sooner or later ko na mag-assign na lang ako ng additional pa for this part. So by next week, we will be discussing subgroups, which is 1-5. 1-5. Okay? Did you take note, Micaela? Naku, wala. Nawala pala. Okay, thank you, Ma'am Ilocanang Inday. Salamat po sa pagpunta ninyo sa ating abstract algebra class. Yan, we're still waiting for our student to come in again. Dale, are you still there? Dale, one of my students, is also in the YouTube channel. Okay. Na-take down mo ba, Micaela? Number 25. Is also part of your take-home, Micaela. Number 25. Is a true or false question. And then, I think I mentioned number 23. Number 23. And also number 20. Did you take note, Micaela?
Opo.
Okay, so those are the additional take-home. Then by next week, we'll be moving on to another topic, which is subgroups. Anyway, the remaining topics here, I may assign or not. These are more on ano na to eh, more on subgroups na tayo. Ito mga hypnosis na to is just proving. We may not focus much on proving, no? Puro to show na to, no? So more on operational lang tayo rather than proving. Okay, so we'll move on to 1-5 by next week. Okay? Micaela? Ayan, so yung mga samples sa book, you may practice them. But what I'm providing here is just the lecture, the slides. And some samples that we are solving in the exercises. Okay? Dale, are you still there? You have some comments, Dale? Dale? Dale, are you still there? Ayan, so they're still here. So I hope you take note of all of the additional take-home. So we'll be moving on to, ayan, so no comment na si Dale. Thank you, Dale. So we'll be moving on to 1-5. I hope that you will read the entire material because what I'm presenting is just the slides. In fact, we cannot verbatimly look at that. No, it's for your readings. Nevertheless, we're highlighting here some main points, concepts. I'll make it more conceptual, computational rather than proving. We don't have much time in proving kasi improving more on ano yan, yung mga BS math talaga, no? But for BSED math, it's more conceptual, computational ang ating approach even in abstract algebra. Okay? So other thoughts, Micaela, before we close in a word of prayer?
Wala po.
Okay, sige, let's pray. Father in heaven, we thank you for this day. Thank you for this opportunity where we could discuss this portion regarding groups and its properties. There are examples and that we need to consider on how to describe these properties. of the groups. Perhaps allowing us to know the appropriate computational techniques necessary for describing a group, whether that be abelian group or perhaps defining a group in terms of its associativity, uh, identity, and inverse. We thank you, Lord, for this opportunity where I could impart some of my thoughts on this course. I hope and pray that the students may learn from this conceptually and computationally, and eventually that they may apply whatever they learn from this course and other courses similarly on the manner that this had been taught to them on how they acquire information, computational techniques, and teaching strategies applied to their classroom. We thank you, Lord, and may you continually guide us throughout the day, even this week. This is our prayer in Christ's name. Amen. Okay, thank you, Michaela and Dale. See you next week. And see you tomorrow also for our Edu 115, Michaela. Okay, bye-bye.